Hello everyone, my name is Cheng Shuze. Today, our group will present about momentum flow analysis using a fire hose nozzle as our application. Fluid mechanics is the study of how liquids and gas behave when they are rest or in motion. It is an important subject in engineering because it helps us design many everyday systems, such as water supplies networks, pumps, turbines, aircraft, and firefighting equipment. Our application focuses on momentum flow analysis. Momentum is the product of a fluid's mass and velocity. When the velocity or direction of a fluid changes, its momentum also changes. This change in momentum produces a force, which is explained by Newton's second law of motion. Engineers use this principle to calculate the force acting on equipment that carries moving fluids. A fire hose nozzle is one of the best real-life examples of momentum flow analysis because it converts pressurized water into a high-speed water jet. At the same time, the nozzle experiences a reaction force that firefighters must control while operating it. This is fire hose nozzle. A fire hose nozzle is attached to the end of a fire hose to control the direction, pressure, flow rate, and spray pattern of water during firefighting. It is widely used by fire departments, industrial plants, airport, and emergency rescue teams. For our example, we select an adjustable fire hose nozzle. It is usually made from lightweight aluminum alloy. Weighs about 1.8 kg, has a 25 mm outlet diameter, and operates a pressure of 7 to 10 bar. The working fluid is clean water. The nozzle works by reducing the outlet area, causing the water to flow at a much higher velocity. This high-speed water jet can travel a long distance and effectively extinguish fires. However, because the water's momentum increases, an equal and opposite reaction force is produced, pushing the nozzle backward. This is why firefighters need to hold the nozzle flames during operation. This application clearly demonstrated how momentum flow analysis is used in real engineering. It also shows why understanding fluid mechanics is important for design firefighting equipment that is efficient, reliable, and safe to use. That's all for my part. Thank you.
Hello everyone, my name is Steve Hong. Now I will explain how a fire hose nozzle works. First, water is pumped from the fire truck into the fire hose. The water then travels through the hose under high pressure. When the water reaches the nozzle, the outlet area becomes smaller. Due to the reduction in area, the water velocity increases significantly. The high-speed water exits the nozzle as a powerful jet and is directed toward the fire. As the water accelerates and changes momentum, a reaction force is generated on the nozzle. This is why firefighters need to hold the nozzle firmly during operation. Alright, next. I will explain the working fluid and principle. The working fluid, as we know that we use the water. Water is suitable because it is readily available, non-flammable, and highly effective for all absorbing heat from fire. Next, the first principle is the conservation of momentum. When the water leaves the nozzle at high velocity, its momentum changes, producing a reaction force on the nozzle. The second principle is Newton's third law. For every action, there is an equal and opposite reaction. As water is pushed forward, an opposite force acts on the firefighter holding the nozzle. Third principle is Bernoulli equation. As the nozzle area decreases, the water velocity increases, resulting in the change in pressure and kinetic energy. That's all for me. Thank you.
Hi, I'm Tashalin and I'm going to explain about the Reynolds number. Assume the water density is 1000 kilograms per meter cube, the velocity is 28 meter per second, the diameter is 0.025 meter, and the dynamic viscosity is 0.001 PAS. The RE is 1000 times 28 times with 0.025 divided by 0.001, and the RE will be 700,000. Since the RE is bigger than 4,000, the flow is turbulent. The next thing I'm going to explain about is the Mach number. The velocity of water is 28 meter per second. Speed of sound in water is 1480 meter per second. To calculate the Mach number, we have to divide the 28 with 1480, and the Mach number will be 0.019. Because the Mach number is much lesser than 0.3, the water is treated as an incompressible Mach number in fluid.
Hello, my name is Muhammad Shahid. Uh, wait. Moving on to the suggestion for improvement to enhance the nozzle performance, we'll propose four main solutions. First, we can use lightweight materials like aluminium alloys to reduce weight and operator fatigue. Second, we should install a removable mesh filter to trap sand and rust, preventing any nozzle blockage. Third, we highly recommend regular maintenance and inspection to clean internal component and check for wear. Lastly, we can develop advanced nozzle geometries with better spray control to maximize efficiency and reduce water wastage. Next, moving to the next, conclusion. To the conclusion, to conclude, the firefighting hose nozzle is an excellent example of momentum flow analysis. Throughout this project, we successfully analyzed that the change in water velocity creates a 288 Newton backward reaction force. Our calculation also show a high Reynolds number of 700,000, confirming the flow is fully turbulent, which is essential for a high energy water jet. While issues like frictions, losses, and blockage exist, they can be solved with proper engineering improvements. Ultimately, a deep understanding of fluid mechanics is crucial to ensure higher safety and efficiency in emergency operations. That's all from our group. Thank you.
Next, I will explain my part. My part is number 7, 8 and 9. Number 7 is about friction. As water flows through the hose and nozzle, friction occurs between the water and the inner surface. The friction causes pressure, loses and slightly reduces the outlet pressure and the velocity. Next, number 8 is laminar or turbulent flow. The Reynolds number is approximately 700,000, which is far above the critical value of 4,000. Therefore, the flow inside the nozzle is turbulent. Turbulent flow enhances mixing and allows the nozzle to produce a powerful jet for firefighting. Number 9. Problems encountered. First is high reaction force. The large reaction force makes the nozzle difficult to control, especially at high flow rates. Second, pressure loss. Friction in long hoses reduce water pressure at the nozzle. Third is nozzle blockage. Sand, rust or debris can partially block the nozzle and reduce water flow. Fourth is corrosion. Continuous exposure to water and chemical may cause corrosion of metal parts. Fifth is water wastage. Improper spray adjustment may waste water during firefighting. That's all from me. Thank you.